So I'm Felix Heim. I'm representing the University of Cologne, and together with Professor Andreas Zilges, I'm responsible for the transnational access at the University of Cologne within the ChETEC project. Next slide, please. So this is a picture of our Department of Physics. Unfortunately, it's only some simulation. Most of those buildings are under construction or under extensive renovation and modernization. So in the future, we hope that our building and our department will look like this. Next slide, please. I will give you some numbers just very briefly. So we in total have 4 professorships in our institute, and the largest or the most people in our institute are doctoral students or bachelor and master students. So lots of very young students, which are of course very motivated and doing a large variety of different experiments. Next slide, please. Our institute, so we're very proud of our mechanical workshop in our institute, which is very well equipped and well experienced with a large variety of different experimental setups, different detector arrays, target chambers. That means for any user that comes to Cologne for transnational access, we can assist and we can support them when they bring their own setups, their own detector setups, for example. And in many cases, together with our mechanical workshop, we will find solutions to install and implement the user's own setups as well. Next slide, please. The same is true for all kinds of electronics. So if any user brings their own electronic devices or has any problems, we have an in-house electronics workshop that can assist with any kind of problem. Next slide, please. We are very lucky and very happy that we have our own target laboratory in our institute, which is as well very experienced and can produce targets of all kinds of geometry and thickness, using different methods. This is just some pictures of targets that have been produced in the past. So again, similar to our mechanical workshop, we can assist with production of targets or just with some knowledge. So if there's some advice or some help needed, this is something a user should contact us well in advance. If a user needs to need help with the target production, just contact us well in advance, so we have some time to discuss about production of targets. Next slide, please. At present, we have 2 accelerators at our institute. The first is our 10MV Tandem accelerator that can produce basically all kinds of ions. In most cases, we use protons or alpha particles. The beam intensities are given at the bottom of the slide. It's not that as much as we would like for many experiments, but at present these are our limits. In addition, we have our 6MV Tandem, which is at present only used for accelerator mass spectrometry. Commissioning of this accelerator for protons and alpha particles is ongoing, but due to the pandemics last year, this hasn't been developed a lot. So we hope that this at some point in the future will be possible, but at present we can only offer transnational access for our tandem accelerator. Next slide, please. Let's come to some research. In principle, we can perform all kinds of cross-section measurements. So total and partial cross-sections can be measured using the HOROS detector setup. This is in the picture shown on the upper right corner. This detector setup consists of 14 high-purity germanium detectors, which have in total a very, very high gamma ray detection efficiency. And those cross-sections can be used for all kinds of astrophysical application. For example, gamma process nucleosynthesis. Those calculations or those cross-sections are often used to study the underlying nuclear physics properties, which are very, very important for network calculations. In addition, we have a low background detector counting setup in the second basement of our institute. This is the picture on the lower right corner. So we can also use the activation technique where we measure unstable activated targets. Next slide, please. This is an example of just two experiments we have performed in the last years. On the left side, a typical proton cross-section results, and on the right side, a typical alpha experiment. Both of those plots also show the typical range of cross-sections that can be measured, which is in the range of a few microbarns. Next slide, please. In addition, we can measure primary gamma rays. That means after any kind of capture reaction, we can measure the direct emission of gamma rays, which can be important for different applications. And also we can measure angular distributions. So our 14 germanium detectors, which are mounted in the HORO setup, are mounted under 5 different angles. So in principle, it is possible to measure all kind of different angular distributions. Next slide, please. So with this, I finish in time, hopefully. For any questions, any contact, you can see our contact. So if any user has interest in transnational access, similar to other facilities, it is very advisable to contact us before applying via the GATE server. So to talk about physical feasibility, for example. Thank you.